Hello, everyone. Today we're going to go ahead and learn about graphing transformation of inverse trig functions. It sounds intimidating, but it really is not. So let's go ahead and start with this quick do now. So go ahead and identify what function is associated with each graph. So make sure you are titling this on your table of contents. So go ahead and pause the video and identify the given functions. Okay. So if you're still not familiar with this, a lot of the times arc sine and arc cosine are a little bit confusing, but from these three graphs, these three parent functions, we can see that tangent is the one that looks different, and we know that because our tangent looks like a cubic function, but the arc tangent is horizontally. So we can tell by this domain from negative infinity to positive infinity, this right here will be our arc tangent of x. If you are lost from where I got these functions, please refer to 5.1 notes. Those right there is where we actually graph all these three inverse apparent functions. Okay, so now we're just left with this function right here, and we can see that this function is, the range from this is from 0 to pi, and the domain is from -1 to 1. This right here, the one that is completely above the x-axis, this is your arc cosine of x. Okay. The one that is half of it is below and the other half is above, this is right here, this is your arc sine of x. Okay, so hopefully seeing this and seeing 5.1 notes, this really helps you out in remembering how they look like. Now you're probably thinking, why are we looking at this? Why are we seeing this again? Well, this right here today, we're actually gonna transform them. We're gonna stretch them, we're gonna squeeze them, we're gonna shift them left, up, down, right. So let's go ahead and do that. Keep in mind, today is Wednesday. This homework will be due on Tuesday. 5.1 homework is due tomorrow. Okay. Alrighty. And we do have a quick quiz on Friday. We will review for it just a little bit, and then we'll take it. Okay. All right. So we're gonna learn how to graph inverse trig functions. Okay, so if you don't have those notes right now, go ahead and pause the video, look for those notes. If not, go ahead and write them down one more time. So go ahead and pause the video and write down these notes. Friendly reminder, these are for 5.1. Make sure your arc cosine, you do know the domain and the ranges. For your arc tangent, you do know your domain and range. And for your arc sine, you do know your domain and range. And the basic shapes that they form. Keep in mind, these should have solid dots. I totally forgot that. And these right here should have arrows because they are restricted in their domain and they are restricted in their range. Okay, awesome. So how are we going to go ahead and transform these? Well, I'm going to go ahead and show this idea, and I promise that this would have been way more fun in class because I show up with the lab coat. This is the idea of DR.DABC. So this is something that I teach the students on a funny way to remember how to do these transformations, because a lot of the times, I mean, as you can see now, we're in Unit 5, and we've been seeing transformations of functions ever since Algebra 2, ever since my review of Unit 1. Okay. So what the heck is DR.DABC? Well, DR.DABC refers to the transformations in the domain, transformations in the range. So domain and our range. Okay, so you're probably thinking, what the heck? I still don't understand. Well, keep in mind, we will be working with inverse trig functions, and the general shape of these are our amplitude times our inverse trig, and then we have horizontal compressions, horizontal shifts, oops, it should be a bracket, and plus d. Okay, so all of this right here, and let me go ahead and hide my video and hide my control panel. Okay, so all of this right here is going to go ahead and show us that, hey, I can find these right here, these terms right here, this A, this B, this C, and this D. Each one of those is going to go ahead and transform my parent function into whatever it is. So what I'm saying here is that if you use these and you multiply it to your domain, your B, and you add your C, which actually should be subtract your C, you can actually go ahead and find the new domain. The same thing goes for our range. If I get the range from the parent functions, whatever that may be, and I go ahead and multiply by the amplitude and add the value of d, I can find my new range. Now, I didn't pull these from thin air. The idea comes from the following. The A right here. A here is a vertical shift, a vertical compression. So I want you to think about it. A is goes ahead and messes with your vertical, which is your y's, and all our y's, the set of all the y's is called our range. That's why I'm multiplying times r. D is the vertical shift up and downs. Up and downs are your y value, so that also affects your range. My domain got multiplied by b and c. Keep in mind, this c and this b, they will go ahead and work the opposite of what you're thinking. So if I think b is a whole number greater than 1, I'm going to say, oh man, it's going to get bigger. But no, it lies to me. It's actually the reciprocal of that. The same thing with c. If I have a subtraction, I'm thinking, oh snap, it's going to go to the left. Actually, no, it goes to the right. So a lot of the times I will write this as d times 1 over b minus c. Okay. And I'll have all of these notes right here, guys, to simulate my notes, because when I do my homework, I usually have my notes on the side, and hopefully you guys do too. Okay, so go ahead and write down these notes real quick. How do we actually do this? Well, as I mentioned, you should be familiar with your parent functions. Then we identify all the transformations, meaning the A, what does the A do? What does the B do? What does the C do? What does the D do? So that's how we identify the transformations. Then we apply those transformations using the DR.DABC, right? DR.DABC is rad. So range gets multiplied by amplitude and added the vertical shift. The domain gets multiplied by 1 over b, or b minus c. Okay. Now, if you are familiar with that, the horizontal movements goes ahead and does the opposite of what you think, you're okay with this one. If you keep forgetting that, I might recommend that you do this one right here. It's the same thing, but this one actually makes you do the reciprocal. Whether this one right here, you just should know that it does it. Okay. And last but not least, graph the new sketch. Sketch the new graph. Awesome. So go ahead and pause the video right here. And I want you to identify what is the parent function that I'm using, what will be the domain, and go ahead and see what we will go ahead and multiply with. Okay. So hopefully you were able to pause the video and find those solutions. So in here, in this value, what we went ahead and did to make this easier, and hopefully my students do it too, is I went ahead and got that value of d and I put it to the front. Keep in mind that there's a value, so you can go ahead and move it wherever you want, okay, as long as you don't forget it. So ideally, I have pi plus 3 times arc cosine 1/2 x minus 4. So hopefully you're able to see that, hey, this is an arc cosine, so I'm going to be working with my arc cosine, meaning these are going to be my parent function domain and range. So -1 to 1 is my domain, and 0 to pi is my range. Okay, so far so good. Let's go ahead and identify the transformations. I have pi right here, meaning it's going to go ahead and go up pi. So it's going to go ahead and go up pi. This is my d. This is going to be a vertical movement. And then my value of 3 is a vertical stretch. Vertical is the key word. So this is also going to mess with my range. These right here, this 1/2 and the -4, keep in mind, these are inside the brackets. These are inside the parentheses. This stuff is going to go ahead and lie to you. I'm thinking, hey, this horizontal of 1/2, it's going to go ahead and squish my horizontal, but no, it actually stretches it horizontally by the reciprocal. So therefore, it's going to be, b is going to be a 2. My c, however, is a -4. In my head, I'm like, it's going to go ahead and make it go left. But no, it actually makes it go right. It does the opposite of what I'm thinking. It's counterintuitive. If you are lost on just identifying the transformations, I made a video on how to find them. Okay. The next thing we're going to go ahead and do is we're going to go ahead and apply our equations. Keep in mind, I went ahead and wrote it like this because a lot of my students forget to do the reciprocal of c and I'm sorry, the reciprocal of B and do the opposite of C. But if you are okay with it, you can go ahead and just do it like I normally do. And that is getting your domain -1 and 1. Then you're going to go ahead and multiply it by your B. And you're going to go ahead and subtract your C. So in this case, it's -1 and 1. B, right? B is the reciprocal. It's 1 over the 1/2. It is the reciprocal of 1/2, which is 2. So multiply it by 2 and subtract your C. So the opposite of -4 is a +4. Okay. So this looks a little bit scary, but ideally you're just doing PEMDAS. So you distribute the 2 into both parts. So now this is -2 and 2. And you go ahead and add a 4. So -2 plus 4, that is 2. And 4 plus 2 is 6. This right here is your new domain. Okay. Easy peasy, right? Let's go ahead and try the next one. We have the range is from 0 to pi. And keep in mind, DR.DABC is rad, so it's going to be multiplied by a, and we're going to add the vertical shift. So it's going to be 0 to pi. My a in this case is 3, so multiply by 3. And I'm going to go ahead and add my pi. Don't be intimidated by this because this pi is still a number. So if I distribute my 3 into both parts, I get 0 times 3 is still 0, and pi times 3 is 3 pi. Don't forget to add your pi. So from here we have 0 plus pi, that is pi, whoops, that is pi. And 3 pi plus pi is 4 pi. This right here is my new range, okay? Awesome. So as we mentioned, let me just quickly summarize this because this might have been a lot of information. Arc cosine, I went ahead and used my notes and saw that, hey, arc cosine looks like this graph and it has this domain and range. So I went ahead and put it right here. This is the original domain and range. Then I identified my parent functions by using this quick little template. But hopefully by now you know what vertical shifts are, horizontal compression, stretches, and vertical and horizontal shifts. So ideally, that's what I'm applying to my range. So keep in mind, if something is affecting you vertically, it's going to affect your range. If something is affecting you horizontally, like B and C, those are going to affect your domain. Okay. Alrighty. So from here, all we have to do is sketch it. Now, I know a lot of students went ahead and saw this shape right here. And be like, oh, I just have to draw this same curve right here and make it bold. I just have to go ahead and draw this shape right here. Well, ideally, yes, but we're going to go ahead and make some modifications. What modifications? Well, we're going to go ahead and change the domains and the ranges. So the new domain, according to this, is 2 and 6. This graph is restricted to be between 2 and 6. Okay. My range is also restricted. It is now pi all the way to 4 pi. Ideally, you want to put the 4 pi on top because it is a bigger number. So notice how much it already changed. It's not going to be between -1 and 1. Now it's all completely in the first quadrant. So what I like to go ahead and tell my students is to go ahead and make this quickly little box right here. So that's the best I can do, guys, right now. Okay, and then you're going to go ahead and follow this pattern. So let me go ahead and do it in purple. Yeah, purple. So according to this, I have a point in the top left corner. So top left corner is right here. And I have another point in the bottom right corner. So I'm going to go ahead and do it here. So at the point 6 and pi, and I have another point at 2 and 4 pi in height. Okay, so I'm going to go ahead and try to curve this as best as I can. To be more exact, guys, you can go ahead and find the midpoint. So in order to find the midpoint, you add the 6 and the 2 together. That gives me an 8. And if I divide by 2, I get a 4. Hopefully by now you're using graphing paper and you should be able to see these a little bit better. Or not, since it might not be to scale all the time. Okay, the next one is 4 pi plus pi. That's 5 pi. And then you divide by 2. So something like that should be our midpoint. So ideally, our graph will go ahead and be like this red one right here. I'm trying my best to curve it the best that I can, but it's not that perfect. Okay, cool. Ideally, if you want something that to be really sketched to the T, you can go ahead and use desmos.com. That will go ahead and give you a nice, pretty sketch, and you can mess with the increments so you can get a uh, perfect interval. Okay, awesome. So we went ahead and used the near domain new range to find out where it was. And so ideally, this is what it changed from the parent function to this one right here. Pretty neat. I do have a meme for us, so hopefully this makes you giggle a little. I really do enjoy these Winnie the Pooh memes. Awesome. Okay, I'm gonna go ahead and ask you guys to try this one. So go ahead and give this one a try. Ideally, it is the same idea. This is gonna be an arctangent. So I'm gonna look at my notes, arctangent, and I'm gonna go ahead and borrow this information. Okay. So go ahead and give those a try. Find out what your D is, what A is, what B is, and C. Okay. So hopefully you were able to see that your domain is from negative infinity all the way to infinity. My range, be careful, go ahead and put parentheses here because we have horizontal asymptotes on the top and at the bottom. Okay, so we have these right here. And since the domain is infinity to negative infinity, that's why that one also has a parentheses. Okay, so let's go ahead and apply our transformations, knowing that D is negative pi, A is 2, B is going to be the reciprocal of 2, so 1/2, and C is going to be the opposite of 1, which is negative 1. Okay, so let's go ahead and begin. I'm going to go ahead and get my domain, which is negative infinity to infinity. I'm going to go ahead and multiply by 1 over B, so 1/2. And I'm going to go ahead and add the opposite of positive 1, which is negative 1. Okay. So this right here goes ahead and confuses a lot of my students, but hopefully it doesn't mess you up too bad. We have a very, very large number. We have this idea of infinity. So if I get infinity, the largest number I can think of, and if I divide it by 2, this number ideally should be very, very large, and I can still consider that infinity. Same thing goes if I distribute the 1/2 to the other infinity, I should still have infinity. Okay, last but not least, I'm going to go ahead and subtract the negative 1, so -1. Okay, so this right here is still negative infinity to infinity for my new domain. So this raises a lot of questions, like can I just assume that this negative infinity would always stay the same? Well, I want to tell you yes, but I still want you to go ahead and practice this skill. However, it does change this little point right here, this point right here at the center. So keep in mind, we will still be changing that point in the middle. Okay. Now, for my range, I have that I was given negative pi over 2 to pi over 2. This right here was affected by my amplitude stretched by 2, and it was shifted negative pi down. Okay, so if I distribute a 2 into both parts, I get negative 2 pi over 2, comma, 2 pi over 2 minus pi. Keep in mind, if I have 2 pizzas divided by 2 people, each person gets a pizza, so I should have negative pi 2 pi subtracted a pi. So from here, I got negative 2 pi because I have negative pi minus a pi, and then pi minus a pi is 0. So this is my new range. Okay, awesome. So let's go ahead and continue by graphing this here. So ideally, this should have an arrow. Sorry about that. And we can see the horizontals. So we're going to go ahead and sketch this out given our new domain and our new range. So our new domain is from negative infinity to positive infinity. So I'm not going to go ahead and sketch that out, but I am going to go ahead and find the new range. My new range is the lowest I can go is this horizontal asymptote, which they are telling me is negative 2 pi and the other horizontal asymptote is right on the x-axis. This is 0. Okay, so ideally I should have something like so that is going towards positive infinity and negative infinity. Now keep in mind, I have this point right here. This point was originally on my my origin, but I can go ahead and find out its midpoint from the vertical. So the middle between negative 2 pi and pi is negative pi, right? That's right in the middle. Add them together, divide by 2. However, my horizontal went ahead and got shifted 1 unit to the left, right? Because the +1 in my horizontal is 1 unit to the left. So instead of it being in the origin, it's going to be 1 down. So it's going to be something like this. Okay. So we were able to find the middle between 0 and 2 pi was negative pi, and this right here, what got shifted 1 unit to the left. That 2 did not affect us because it was 0. If I go ahead and compress 0, it's still right there at 0, but the 1 to the left did change it. Okay. This is pretty much how you transform them, guys. This is my method. Remember, DR.DABC is rad, but it always helps to have these notes eventually learned or memorized. But that's the only way that it makes this a little bit easier versus the other methods that you have seen. In order to have practice in this, guys, I want you to go ahead and try these next 3 examples. This will be due on your notebook, and I want to go ahead and have it graded by Tuesday, so go ahead and give that a try. If you are stuck for any reason, please send me a message and I'll help you out. Okay. As always, guys, it's been a pleasure, and hopefully this video helped out. Okay. I'll see you on the next one. Bye-bye.